All right, hello, my wonderful students. This is part 2 of foldable number 1, and for this one we have two logarithmic functions. We have our log of 8 to 32 is equal to our a, and we have a log of 3 of 81 is equal to our a as well. In the book it has x here, but this x is actually the y, so it got really confusing. So I just decided to change this to an a for all four of these to make sure that we don't get confused with something that's already not really confusing, but hard to understand if you mess up the variables. Okay, so I guess I can just write down the thing again here. So we're gonna have we're gonna put the y on this side because the way I set it up, it kind of had the a on this side, which should be our y, and then we have our log of blue, and then this is gonna be our green here. 32. Okay, and then I don't know why I put this so high, but so log of 8 of 32 is equal to y. So if you look up on the top, you can see the formula of x is equal to b to the y, and our x is our 32. So our 32 is going to be here. So 32 is going to be equal to our b, and then to the a power. We can, there we go. Oh, I did it again. It's not supposed to be b, it's supposed to be 8. Get confused when you're like rewriting stuff from the top. So we have 8. So 32 is equal to 8 to the a power. So this is it's something that we technically haven't really done before, but we have done before, but we haven't really done it this way. So we need to find this power in order to equal this. Well, the easiest way to do this is to try to figure out the base of this right here, right? So what we can do is we can change these here. So I'm going to rewrite this in black just so we have. So I know 8 and 32 are both can be bases of 2. So for example, 32, if we look at our cheat sheet, is 2 to the 5th power. And 8 is 2 to the 3rd power. But we also have to include our a there. So it's going to be 2 to the 3rd power times a. So, but this is a rule of exponentials, power property of exponentials, which we went over a while back, that if you have the same base here, that means the tops are equal to each other. So that means that 5 is equal to 3a. Because if this is 2 to the 5th power, this has to be 2 to the 5th power as well, because it wouldn't work, it wouldn't be equal if that wasn't true. So that means this 5 has to equal this 3a. And this was something we did like first semester. So all we have to do now is just solve for 3, or solve for a by dividing by 3 to both sides. This reduces to 1, or divides to 1, and we have that our a is equal to 5 over 3. But now let's do a little check. So if we were to plug in our 8 here and we add 5 to the 3rd power, just so if we remember, this is the cube root of 8 to the 5th power. Well, the cube root of 8 we know is 2, and 2 to the 5th power we know is 32 because we just kind of went backwards here and found that there. So we do indeed know this does work. All right, now let's go to this next one over here. Once again, I'm going to rewrite this in the color-based form. So it's going to be the log of 3, which is going to be in blue, of 81 is equal to our a, which is in red. Now we can rewrite that in the form we have. So we have our x, which is 81, is equal to our 3, which is our base, to the a power. Similar to what we had before, we can see that, well, it's kind of similar. This is already already a prime form. So we don't have to worry about trying to redo this one like we did the 8 over here. But we know that a, or 3 to the 4th power is 81. So we can rewrite this one here. I'll go back to black again. So we have this 81 is actually 3 to the 4th power. And this is still 3 to the a power. So we know, once again, if we have the same base, we can say that the exponential values are equal to each other. So we have that 4 is equal to a. And when we do our check, it's going to be kind of easy because if we do our check on this one, we can see already that if we plug in 4 here, we have 3 to the 4th power is equal to 81 because we know that from before. Okay.